Shake Table1 by Drew Kumans and Gabby Perez. One of the first processes of building is making a sketch. So, first, Gabby and I used Sketch to make a plan. We estimated about how long each straw was and how long we wanted it to be. The dimensions of our sketch were 36 centimeters for the height of the side and 19 centimeters for the floors. After Mr. C approved our design, we started to work on our tower. On the bottom of our tower, one of the building codes was having extra support. So Gabby and I drilled 4 holes near the sides of our cardboard surface, stuck straws through them, folded them down, and taped them. To secure the top, Gabby and I latched straws to the existing bottom part of the tower to make it sturdy. The next step of our building process was to make the walls. We first made the square formation on the bottom so the walls could stand up tall. Then Gabby and I put the walls up using a special method Mr. C taught us that used less tape and was more successful. Finally, the tower was ready to move on to the next step of the building process. Gabby and I have built all the walls and are in the process of attaching crossbeams. We have crossed 2 pieces, taped them on the sides, and then taped them in the middle to make sure that the straws don't slip out of place. We also put 2 straws in the middle of the tower to make sure the sandbags don't fall through the floors. Our final process of construction is done, where we had to build a roof following the building code. We did a basic style roof that just went inward. Our roof was made with 6 straws and we had a few bumps during the process. Our original plan was to make stairs going up as a roof, but that didn't really work, so we switched to something simple. We decorated our roof with cartoon pandas and realistic pandas to give our tower some flair. Our tower is completely done. We used Sketch again to put in the new measurements of our tower. The new total height of our tower was 47 centimeters, not counting the roof, and 21 centimeters for the floors. Later, Mr. C told us to add a roof to make our tower different, so we added a few centimeters. To test the strength of our tower, my partner and I put 4 weight bags on our tower. We put 2 on the first floor and 2 on the second floor. Then we checked our tower to see if any parts of our tower couldn't stand the weight of those sandbags. Gabby and I had to fix up a few areas for our tower to have full strength. For our tower, there was a few things we needed to strengthen. One of them was the middle so the sandbags wouldn't collapse to the floor. These 3 straws were positioned in a way so that they supported one another. The strongest part of our tower was the corners. Our tower's corners were the strongest because that's where all the straws come together. Gabby and I connected all the straws at the sides with loads of tape, which also make it very strong. Our tower's weakest part was the single straws that made up the floor. That was our weakest part of our tower because it was only a single straw and it doesn't have any straw supporting it. My partner and I used a lot of tape while connecting straws together. In the corners, we used the most tape because there was very many straws going to different places starting from there, so we had to connect them all to the wall to make them sturdy. For the flooring, Gabby and I had to measure how wide our tower was because we already put support in the middle, so we had to cut 2 big pieces of construction paper and tape it around the support beams. Gabby and I measured the top floor and cut 1 big piece of construction paper to cover the floor.
This is for a minor earthquake.
Bending.
demonstrate table lab testing, Mr. C put a device that measured the types of earthquakes. The x-axis was the side-to-side motions, which were the strongest waves for our tower. The y-axis was the push and pull motion, which were the weakest waves, and the z-axis was the up and down motion, which were the second strongest waves. Our building supported 14 sandbags. Our building first failed because of the cross beams. They failed because they weren't connected to the corners very well. If I would change anything right now, I'd add a straw supporting the cross beams so they wouldn't fail. I learned that if you have to build an earthquake-proof building, you need to have straws supporting your strong parts, or else your strong parts won't do very well. My favorite part of this lab was building the roof. I love building the roof because I love the different designs. I also love decorating the roof with cartoon pandas and realistic pandas. Yeah!
Our building supported 14 sandbags. The cross pieces failed first. They failed because they had the least amount of tape supporting them in singular straws. I think that we could have added more tape to the cross pieces and the base. That would make the tower stronger. I learned that you have to make sure that the base is secure or the whole building will fall down. I like that we got to design our roofs and were not given specific guidelines for building them. I also liked how we got to use construction paper to enhance our tower.